Thank you, Colleen, and welcome everybody. Really happy to be here. Really happy to be presenting here with you all on one of the topics that's quite fun and something I really enjoy. So as we begin, as Colleen mentioned, make sure you start your labs. Make sure you, if you're going to be following along with me, that you get the boxes started, that you get logged in. Okay. And let's go ahead and get started. I'm going to share my screen, the slides, as well as the lab, and we'll go from there. Before I do spend some time on the slides, I want to quickly go through the lab, the setup, what you need to start. So things are already happening in the back end. The boxes are ready while we're going through the slides. So as you log in, under my cohorts, you see the free lab, the live lab stealing credentials by phishing with Word. Click on that. And there's some information about the meetup as well as about myself. And then you go into hands-on lab, click on the lab name. And on the right side, you see the start lab button. Make sure you start that. And it will start your Kali box. If you click on settings over here, right here, right, you are going to see that you have a Linux box, which is going to be Kali Linux. And then you'll have a phishing with Word box, which is a Windows box. I'm going to be, the way we'll use that Windows box to emulate, first prepare our payload, but also emulate a user clicking, is by remote desktoping into it from Linux. So you'd want the Linux desktop environment. Okay. All right. So that's the basics about it. The login in here. So my name is Qasim. So my login is CyberLab and the reverse of my name. So MISAQ. Now you all know my password for this. Okay, so it's CyberLab and then reverse of your name to log into it. Okay, and then your Windows and Linux boxes either are already starting or may already be running in here. Okay, let's go ahead and start talking about the topic in here today. So we're talking about phishing with Word, which is a pretty common scenario in penetration testing world, as well as the black hat, the dark side of testing, or some might say. And we're going to be talking about two different approaches around phishing today. We will first begin with discussing phishing just to make sure everybody is on the same page, that we level set. Then we will talk about the first approach, which is most common, which is using macros for phishing. It uses Visual Basic for Applications, VBA, that some of you may already be using to make your Microsoft Word or Excel work much more efficient, but you can also use that as a programming language for attacks. Next, we'll talk about a different approach that I learned from a former colleague of mine, Marcello, the person who created the CrackMap exec tool. And I've been using it very successfully since. And I know it was reported to Microsoft. They just chose to keep it as a feature. They love their features, and we, the pen testers, love exploiting those features. Okay. So a bit about myself. I'm Qasim Ijaz. I am the Director of Offensive Security at Blue Passion. And I am also an OSCP instructor here at Evolve. I teach the OSCP Bootcamp. I've taught the past two, and look forward to teaching the next one starting in August. I'm a hacker by day. I lead pen testing engagements. I do some hands-on pen testing, specifically around Active Directory network pen tests. And I do some teaching. As I mentioned, OSCP. I also teach at conferences. I've taught at Black Hat, B-Sides. I will be teaching a class at the Hack RedCon coming up in September, as well as B-Sides Kansas City. So looking forward to some of those classes in there, and just looking forward to teaching you all right now. So first of all, let's talk about phishing, right? So when we think about phishing, one of the first things come to mind is clicking a link in an email. That is the most basic form of phishing. You'd have a scenario where an attacker sends an email, either spoofing an internal email address, pretending to be a trusted internal user or a trusted external party. And one of the most fun and at the same time, scary phishing emails I saw recently was through somebody pretending to be Facebook. They had obtained a Facebook look-alike domain, and they sent me an email saying that my Facebook post was breaching the Facebook code of conduct. And I had 2 days to respond before my account was permanently banned. And being the person that I am, I wanted to take a look at it because it's always fun to click on phishing links just to kind of understand what the other party's infra looks like, what their infrastructure looks like, maybe try to figure out more about them. And what was really cool about this phishing email was they actually used a Facebook page. So the link inside the email took me to facebook.com. They had created a page on Facebook, of course, which any Facebook user can create, nothing special about that. And they had created a post in that Facebook page that told me to click on another link. So they used Facebook as their anchor to carry out an additional attack. Okay, so impersonating, not necessarily impersonating, but using a trusted third party to carry out their attack in there. One of the more fun ones that I've carried out myself was, and this is really basic phishing scenario, but it was quite fun because of the person targeted. I sent out a phishing email which said your Outlook mailbox is full. Click here to log in and expand your mailbox size. And what was really scary about that was the Exchange administrator, the person responsible for mailboxes, the person who should have known that their mailbox is not full because they have the access to Exchange admin console to check that, clicked on that link, provided their credentials, and once they realized it was a phish, they were not very happy about that. They submitted that same form multiple times with some curse words as passwords. So phishing makes use of a lot of that, the trusted party, or impersonating the trusted party, or oftentimes making use of the current scenarios, right? So what's happening in the world right now, current events. COVID has been a big anchor for phishing for past few years. We've had phishing emails where the attacker would say something like, we know everybody's working remote and we do not have that coffee time together. We do not have that free food Fridays. So here is a $25 Uber Eats gift card for you from the company. And you click on the link, you provide your company credentials, and there is no Uber Eats gift card. It's instead an attacker looking for your credentials. Or I've seen emails where they say something around, we are going to be requiring everybody to come back to office, but we want to know what you think about it as employees. You have a voice. So click here to fill this survey out to let the CEO, the board of directors know if you want to come back to office or not. And that's something that everybody feels very passionately about. So once people click on the links, they're trying to fill out that survey. And what ends up happening is they provide their credentials. Okay. So credential gathering is a pretty big goal in phishing. Then you have goals such as wanting the user to click on a link, trying to have them download some malware to execute. And really think about phishing is you don't need everybody to click on it. You just need one person, one user to fall victim, and that can give you internal access. According to Verizon's DBIR report, which is their data breaches report they create every year, it's a really interesting report to read. I suggest everybody take a look at it if you're interested in cybersecurity from policy, offensive, or defensive side. About 80% of the data breaches Verizon analyzed in 2021, 82% of the data breaches analyzed were from the human element. Now, that's not just phishing. That could be other forms of social engineering. Like I call somebody up and said, hey, what's your password? Right? I show up to somebody's desk and say, I'm from IT. I know your computer is really slow. Let me fix it. And they move over. I now have physical control of their computer. Another thing we are seeing a lot of ransomware actors do is they're paying the employees. So we've seen some cases of that where they would pay the employee to click on a phishing link. Employee can say, well, I did not know that it was a phish. Like, you can expect that from a lot of employees. We security folks chalk it up to, well, the user is our biggest weakness. They're not going to know. They're going to click something. At the same time, that user just made $100,000. So that has been the case in some of the data breaches, some of the phishing scenarios that we've seen. So ransomware actors are making use of that piece of human element. We used to talk about $5 wrench attack, which is an XKCD part also, but at the same time, that $5 wrench attack is also turning into $5 carrot, paying for you to click on the link. The Conti ransomware and a few others have also used phishing as their initial point of entry. And again, you do not need to guess credentials. You don't need to exploit any zero-day vulnerabilities. You just need a user to click on the link, and next thing you know, you've got the internal access. Okay. So when it comes to Microsoft Word for phishing, what you'll generally see is you receive an email that says, here's the attached document that you need to read, and it would require some kind of pretext. The attached document is our new HR policy, or it may be that you receive an email that is destined for HR, but you end up receiving it accidentally, and it talks about salaries. You want to know what your coworkers are making, right? Or it may be something like, here's an invoice, make sure you pay within 24 hours or your account will be closed. Whatever the context, whatever the pretext, the Word document itself can be weaponized in a few ways. So one of those ways, of course, is Visual Basic for applications. So what you see in here in the 3-line code I have, we have a Visual Basic function or a module named auto open. Okay, so what this is doing is the moment the document is going to open, it is going to execute whatever is inside this function. The function is using shell CMD, so it's going to launch command prompt. This is the very basic form of a macro. All it's going to do is just launch command prompt. Not going to be detected by AV, but is not useful to you at all either. Generally, what the attackers are going to do is want a shell. They want the CMD to connect to them. So they may have a payload in there from MSF Venom, which is a tool we talk about in our OSCP Bootcamp quite a bit. Or they may use some other way, Cobalt Strike, Covenant, Empire, some of the C2 framework to generate a payload. Or they may just have a PowerShell command that will create that connection to the attacker's infrastructure. Those will likely get detected, although you can do some obfuscation where you do some very basic things. For example, if this right here is getting detected, well, maybe I do not do CMD, right? Maybe I can create a variable called command, which is equal to string or a character C plus M plus D, right? So if the AV is looking for CMD, it's not going to see CMD, it's going to see 3 separate characters that are then concatenated together. So that is a very common form of obfuscation. You may see some obfuscation where the attacker is trying to get rid of the characteristics that are common to that attack tool. So if you have MSF Venom generating some malware, you may try to get rid of some of the characteristics of MSF Venom in your output. If you're using a publicly available script within your VBA, within your Word macro, then you may try to get rid of things like the comments that may exist in that script, the Twitter handle of the malware author, which is also something that AV is detecting and alerting on. If you're, for example, using Harmjoy's PowerView, one of the things that the AV alerts on is @Harmjoy, his handle inside the PowerShell script. Or one of my favorite forms of obfuscation is just rename variables, rename functions. It may take a bit of effort, but it modifies the script enough that it will bypass some of the more basic AV detections. Okay, so in this form, it is simply what it's doing in here is just launching command prompt. Okay, and as it comes to Visual Basic for applications being used with Word in macros for attacks, Microsoft has put in some protections in place. Right, so you've got a few things. You've got the protected view. as you launch the Microsoft Word with a document you received or email, you download it from web, it has any macros in it, Microsoft has added a new bar, a pop-up, not necessarily a pop-up, but a yellowish bar that'll show up on the top that says, it's in a protected view, do you want to enable content? By default, the content is not enabled, the macro is not enabled. So you have to click enable content for that macro to execute, okay? Another thing they've done is, macros are disabled and you will get a notification about it. Now, these things can be modified on client side, but you as an attacker will not have access to the client's Word application to be able to do this, okay? There are some other attacks that have come out that go beyond this, so they may be able to get around. There was a recent attack around Word that did that, but at the most basic level with macros, you won't have the ability to modify these yourselves, but you can add some pretext to it. For example, you can talk about the enable content itself in the document saying, hey, by the way, you need to click enable content to decrypt the document. One of the examples I've seen in OSCP courseware from OffSec, it has what looks like encrypted content in Microsoft Word doc. And then it says it's sensitive content. We don't want you to accidentally ship it to somebody else. So it's encrypted. Click on enable content to decrypt it. And when you enable content, the Visual Basic for applications is used, the macro is used to replace that doc with something else in there. But also in the back end, a shell executes, right? So you can use pretext to convince the user to click on things, to convince the user to enable content and stuff like that. Sometimes we've seen with phishing, you also do vishing, which is voice phishing. You call up the user and say, hey, I sent you a document. I haven't received a response from you. Can you please open it? Or can you please click enable content if it asks you for it? You just need to figure out a way to convince them, okay? So what I want to do is I want to demonstrate macros in Microsoft Word, and then we'll move on to the next phase of the attack here, okay? And for that, I will use my lab, and I'm going to click this arrow on the right, which will open it in a new window. And I'm going to use the terminal and X3RDP to launch my Microsoft Windows environment. Okay, let me just make it a little bigger so it's easier to read. There's a font. X3RDP with /v, we provide the IP address of the target, -1051.49.41. Yours may be different. With -u, we'll provide the user. If you scroll down on this page in the lab, it tells you the username and the password as well as the command to run, okay? So local user, welcome 1. Wait, welcome 12, not welcome 1. Since the certificate use is used in here to make sure that you don't have any person-in-the-middle attacks happening, and our certificate is not trusted by Kali, it's going to ask you, are you sure you trust this certificate? Since it's internal, we set it up ourselves, we trust it to some extent. So I'm going to type yes or Y and press enter. And now I've logged into the box. One thing I did forget to do, and I'm going to need to close and redo it, is I forgot to provide dynamic resolution parameter, which will help me resize my X3RDP window so it's taking up more space. There we go. That looks better. Okay, so I will click on Start menu and open up Microsoft Word. It might take a minute for Word to open the first time, but afterwards, it'll be faster. right, just give it a minute. What has opened? I'm now going to set up the office by signing in. I'm just going to close it. Then I open a new document. Okay. We're fine. We need to activate it. We have the July 2nd, and we'll be done with it in a few minutes anyway. I'm going to click on File, go to Options in Word, and under Customize Ribbon, I will open the Developer tab. Okay, right here. So File, Options, Customize Ribbon, and Developer. Click OK. The Developer tab shows up. In here, you have macros and the other things. So let's just create a document that will, do something. So let's just say it's got some content, to whom it may concern, blah, 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 something, something, right? Please click enable content to decrypt rest of the document. Maybe we highlight it so the user knows. Okay. Then we go into macros, click macros in here. As far as where the macro will be placed, we want to make sure that it is inside the document. So right now I haven't named the document or anything. So it's by default named document1. And give it some kind of name, the macro itself. I'll just call it macro1. Of course, I need to spell it. And then I click create. And this creates a very basic shell for the macro. And this is your sub function and end sub. This is your comment in here, macro1, the name of it. I'm going to remove that. I'm going to call the macro auto open. So it executes the moment the document is opened. Then I am going to, with some indentation, I just press the tab in there, or you can press 4 spaces. I will provide it the command I want, right? The statement that I want executed. And if you recall from our presentation, it was shell CMD. Okay. So shell CMD. That's all. That's all I want to do. Okay. I will save it. In order for me to save, it's going to ask, do you want to save the document? Now, when it comes to Word documents, the docx extension does not contain macros. So you have to use the older .doc extension or .docm. Okay, I'm going to use the .docm extension, which is Word macro enabled document, and I will click save. And now I can close the macro window, and I can close Microsoft Word. All right. Now, if we go to where it was stored, which I believe was in documents, I open that Word doc. It starts for a minute, and when it launches, we will see that enable content bar, which of course we've told the user to click it so they can see the rest of the document. Especially if you make the pretext important enough, the user is very inclined to click that. Also, the user doesn't necessarily know what it means, right? It was saved as the .docm or macro enabled document, so they may see .docm as extension, but of course you can use .doc and they won't see the difference. Okay, so if you click enable content, we ignore this activate because this is because of licensing. If we click enable content, you see this command prompt open up in the backend, in the bottom. Okay, let's just show you once more, right? So we enable the developer tab. In there, we went to macros. We created a macro named auto open inside the document. And the macro was simply auto open shell CMD. That's all it's doing, is just launching CMD, right? So if the document is reopened, and sorry, it's just taking a minute to open the Word doc. The Word does take a lot of resources. So if you're using a virtual environment, your resources are going to matter in there. But once it launches, we see that enable content again. We click that, and automatically command prompt is launched. Let me remove command prompt from taskbar so it does not show up at all. Okay. Right now, there's nothing on the taskbar as far as command prompt. I click activate. Oh no, that's Word being activated. Let me close this. Accidentally closed the whole window. Okay, let me close this Word doc and reopen it, and it will show you. Okay, you see the bottom command prompt opened up? Because the first time I clicked enable content, now Microsoft Word trusts this document. That's another thing to consider. All you really need is for the user to click enable content once. After that, every time they open it, it will automatically be trusted. So they will never see enable content again. So that's the very basic form of macro. There are a lot of tools available that will help you create macros and do some more malicious things with them. But we're not going to go into that. One thing I do want to note is the more malware you have in your macro, in your Word doc, the higher the chance it gets detected. Okay, so the simpler you keep it, the higher the chance it will not be detected. Now let's switch gears a little bit. I want to talk about the second attack that I want to carry out, and that is using ActiveX controls. Okay? So in order for us to understand ActiveX controls, we need to talk about some precursors to it. First of all, the DNS. So we learned in college that when we want to resolve a name, when we want to resolve a host name or domain name, we ask the DNS, the domain name servers. And the domain name server is know-it-all. They will tell us who we're trying to reach. It will resolve that host name to an IP address, IPv4 or IPv6. However, there are more details to it, right? So before we even go to DNS, the system is going to check if I am the host I'm looking for, if I'm evolvesecurity.com. If I am, then I don't need to go and ask anybody else. If I'm not, then let me check if my etc hosts in Windows or Linux contains the IP resolution, the static resolution to evolvesecurity.com. So if my etc host file contains the IP address and the host name, you can do that in your network, especially when you are not using DNS, or some hosts require that because their IPs are changing often and DNS isn't aware of it, or whatever reasons may be. You often see that in development environments. And then the host goes to the DNS. So first it checks, am I the host I'm looking for? Then it checks the host file, and then it will go to the DNS. Now the DNS won't always know. And if the DNS does not know, your host is going to ask everybody in the network, hey, do you know where this host is? Okay. So in Windows, that is done using NetBIOS and LLMNR. The newer Windows versions, 10, 11, also use MDNS, which is multicast, while LLMNR and NetBIOS are broadcast. The Linux uses Avahi, and then Mac also uses MDNS. So the host is going to ask everybody in the network, hey, do you know who has this host name or the DNS name? Now, the broadcast name resolution protocols is one of the first ways I check in AD networks and enterprise networks if I can get some access. What's happening in here is, let's say I wanted to talk to HR share, and the DNS said, I don't know what HR share is. Well, I'm going to send a broadcast to everybody in the network. Hey, do you know what HR share is? In Windows networks, when some device responds and says, I am the HR share you're looking for, the communication then turns into an NTLM handshake where the hashes are exchanged. Now, these are not NT hashes or LM hashes, which are the local authentication credentials you can use as is and pass them. This is not plain text passwords. These are hash credentials using net NTLM hashing, but there are still things you can do with that. Okay. So before we get into hashing, if you think about this scenario right here, and if you look at the step 4 and 5, right? So the HR file share is responding and saying, I am HR file share. And I just say, okay, that's great. Let's start talking. There's nothing happening in here to make sure the person who responded or the host that responded was in fact the HR share. They could have been an attacker, right? Although this looks like Eddie. I didn't realize that, Eddie. And now it's in a recording. So if the person responding or the host responding claiming to be HR file share may actually not be HR file share. Windows has started, Windows does contain SMB signing, which is going to allow you to validate using digital signatures if the person or the host responding to claiming to be HR file share, in fact, is HR file share. But that is not consistently applied. I still see a lot of networks where SMB signing is not used. And even when it is used, there have been some ways you can get around it. For a while, there was a way where you could just tell the victim, just don't even use the SMB signing. I know you said you want to use it, just don't even use it. And it would acknowledge that and oblige to that. Okay. But if SMB signing is in fact turned on, then there are some ways to still get around it, but they're a little more difficult. But at a very basic level, you sent a broadcast out, you said, hey, does anybody know which our file share is? The attacker responded, said, I am, and now you are sharing the net NTLM hashes. Problem with that is the way NTLM hashes work, the net NTLM hashes work, right? So the protocol itself is the challenge response protocol. Think about this. If you have thousands of hosts in your network, you don't want hashes or passwords stored in every single one of those, especially when you're using AD, the Active Directory. You can have the hashes stored in the domain controller and not on every single host in the world, right? So what happens in net NTLM is when I want to talk to a server, that server and I are going to do a handshake. The server is going to say, okay, well, I don't know who you are. You claim to be Qasim, but there's no guarantee of that. I don't have your hash or your password, so you can't directly authenticate with me. How about you do this? I will give you this challenge to encrypt with your password or your NT hash. So it gives me some string, could be a timestamp, could be just ABC123. And I encrypt it with my password. The server then takes that encrypted blob, which is the net NTLM hash, and sends it over to the domain controller and says, hey, is this valid? Can you decrypt it with Qasim's hash or Qasim's password? Because if you can, that means that whoever was talking to me has Qasim's password, so they must be Qasim. The domain controller comes back and says, yep, I was able to decrypt it, so it must be Qasim. And then file share and Qasim can start talking. Okay. However, there is nothing in here, or at least again, basic level default configurations. There's nothing in here that tells the domain controller that hash that was sent to you was not actually destined for that file share. So we do not, in a lot of enterprise environments, have SMB signing turned on, and we also do not have options provided to make sure that the server providing that hash is actually the one that hash was destined for. Now, one thing though, as we talk about different attacks to net NTLM hashes, as we capture the credential in this step 4 and 5 in here, is you can do two things with those hashes. You can try to crack them, which is what we'll do in here. Okay, you can try to crack the net NTLM hash, see if you can actually recover the password that was used, or you can do what's called relaying of the hash. So you can take this hash that you, the not HR file share, received from that user, and then you can talk to some other share, some other server, and pretend to be that user using their hash. What you cannot do is relay that hash back to that user, because the user is going to know that workstation the user came from is going to know that I was the one who sent it. So there's some spoofing happening. But you can definitely relay it back to anybody else in the network, as long as they're not using SMB signing. We're not going to do that in this because that requires some additional infrastructure. But if you want to do it, net NTLM is the hash we're trying to relay. And NTLM Relay X, part of Impacket Framework, is a really good tool for that. Okay, what we will do in here is we are going to crack that hash. So this is what it looks like. The user on the left attempted to access HR file share, the misspelled share with 2 H in there, and the system couldn't find it. On the other end, the attacker was running a tool called Responder in the network over that Kali Linux, and they were listening for broadcast name resolution. So what you see in this screenshot on the right is, let me just expand it. We have first the MDNS request. The host also sent LLMNR, which is broadcast. So multicast and broadcast traffic was sent looking for HR share. Responder responded to both of them. So that's where you see the poisoned answer. We respond and say, hey, we are the HR share you're looking for. Then the client attempts to talk to us, attempts to access the file share, and that's where you receive the the net NTLM hash in here. So that long hash starting from vagrant all the way down to 000. This is the whole thing you'll put into John or Hashcat, the tools you can use to crack these hashes. Okay. So this is very simple attack. All you really need to do, and all we do generally in our pen tests, is we just spin up a responder and we run it for 5 minutes, look for any broadcast traffic or multicast traffic and try to poison it. We don't like running it more than 5 minutes because it is poisoning any name resolutions using MDNS or LLMNR. So if you have printers or some other devices that are relying on that, you running responder for longer than 5 minutes can impact that because it is going to be poisoning, spoofing, and pretending to be the other shares, the servers that devices are looking for. And of course, the legit users will not be able to connect. So how are we going to exploit it? Well, Microsoft Word ActiveX controls allow you to throw in things like Windows Media Player, where you are adding a Windows Media Player ActiveX object, which the user can click play and it will play a video from whatever source you provide. Could be an HTTP source, could be HTTPS, or it could be what's called a UNC path, which is a path to a Windows file share. Okay, so this is what we're going to do. That some server value here is going to be the Kali Linux box that our responder is running on. And some folder or media file, whatever you may call it, doesn't have to exist. As long as this IP belongs to your Kali Linux, you can look for that traffic. Okay, we've already added the developer tab. So I'm going to close this document. And I open a new document. Actually, I like some of those templates it has. Let's use one of these. Agency letter. There you go. It's got already some content in here. And let's say we've got some content here. And what I want to do is I want to add an ActiveX control. Let's say the document is a training doc, right? So maybe it is HR training, please watch. Okay, maybe it's a security training or whatever training there may be. You just joined the organization and you're getting 1,000 emails with all the trainings you must take. You go to developer tab. Inside developer tab, under controls, you see this briefcase with a wrench, the legacy tools. You click on that, and then you click bottom right. It looks like a wrench, more controls. Click on it. Okay, so under developers, you click on, and inside controls, legacy tools. Inside the legacy tools, under ActiveX controls, you click bottom right, more controls. In here, you scroll down to where you find Windows Media Player, and you click OK. And this inserts that Windows Media Player ActiveX control I was talking about. Right-click, go to Properties, and we are going to provide in the URL field the IP address after following 2 slashes, the IP address to our Kali Linux box. Okay, so open up my Kali Linux terminal. Let me open a new tab in here. My IP here is 1050.140.86. So 1050.140.86. And then I follow that up with a slash and just some video, something, right? .mp4. And it's hard to read it from there. So let me just copy paste it inside the document so you can read what I'm typing in here. So it looks something like, and my word is frozen, so that may take a minute. So basically you have 2 slashes, just like you see here in this doc. And then you have those followed by the IP address to your Kali Linux IP, which you can find by clicking settings in CyberLab, and you have the IPs. Okay, you can also just click the open the terminal in Kali Linux and you'll see it. You follow that by some folder or some file, which doesn't have to exist, just that IP address has to exist. Right. So once you have that document, so it was 10.50.140.85/something.mp4, doesn't have to really exist, just the IP needs to exist. Okay. Now I can save this doc. I can close this, save it. Let's call this HR training. Okay. And then I'm going to go ahead and close this document. And let's close this one. Inside Kali Linux, I will use responder. The syntax, the command for that is responder dash uppercase I, capital I, and then your interface, which in this case is Ethernet 0. I will need to use sudo for this because we are using a low port. It will automatically spin up an HTTP web server. It's going to spin up SMB server on port 445. It's going to spin up DNS server if DNS is not already being used on 53. So you need sudo for that. Sudo responder dash uppercase I or capital I and Ethernet 0 because that is the interface I'm listening on. My password, which is going to be cyberlab, and then my name in reverse. And as you see, it has spun up a few servers, HTTP, HTTPS, SMB, Kerberos, SQL, FTP. Only one we really care about in here is SMB server because that's what we'll be listening on. That's what we're looking for, okay? So now inside Word, I open up the document. Imagine you emailed it to the target somehow with some pretext and they're now opening it. They click on that HR training document, right? And this is what shows up. Now, nothing in Kali yet, okay? Only about a year ago, maybe more than 2 years ago, you didn't have to do anything. You just open the document and Windows will automatically try to, or Word will automatically try to load that ActiveX control in the background. So you would have the NTLM hash at this point. But here, now you have to click play. Once you click play, on the attacker side, we just received the net NTLM hash for that user. As you notice, there was no enable content. And you can spin this document through AV and you won't be able to detect it because there's nothing malicious about this. This is a feature, okay? I clicked play and I received the net NTLM hash for the user. Now I right click, copy that hash, open up a new tab, and I can throw this in a file. Let's call this hash.txt. Control-Shift-V to paste that hash. Right? It was everything from the local user to the end of zeros. Save it. Now, one of the things I need to do is I need to unzip the rocku.txt dictionary, unless we already have it here. We don't have it. Okay, so I will need to unzip the rocku.txt dictionary because the dictionary provided inside our Kali Linux for rocku is actually not unzipped. So if you do ls user share word lists, you'll see rocku.txt.gz, right? But it's .gz extension, which is gunzip, which means that I need to unzip it first. Okay, so what I will do in here is I will run the command for that. So we got the path, which is user share word lists, and then rocku.txt.gz. To unzip it, I'll need to provide gzip-d to deflate, right? But because I'm throwing this under user share, I need sudo access for that too. So sudo gzip-d and then the path to that .gz file for Rocku dictionary. Press enter. It takes a minute. So what we're going to do here is we use John, which is the password cracking tool, John the Ripper. We provided the hash we want to crack and the dictionary that we want to use for guessing the password. So it's going to try each word in that word list or that dictionary against that hash to see which one is able to unlock it. Okay, so John, and then we provide the hash.txt file, which contains this hash, as well as the path to dictionary. So -- word list equals, and then the path to it, which once we deflated it would be user share word list rocku.txt. We press enter, and here we have it. Welcome 12 is the password for that user. And if you go back and look at our instructions that we used to log on, it was welcome 12. Okay, so very simple attack. All we had to do was we created this ActiveX controls in here. So simply just went to developer, went to under controls, legacy tools, and then bottom right, more controls. Found Windows Media Player. There's a lot of other controls here you can use, but I like using Windows Media Player because it goes well with the pretext of, hey, here's a training, you must watch it. Right click on it, properties, and we provide the path to our attack box, whatever that may be. And then you close it, and the user just has to click play. And running responder in Kali, you can obtain the hash for that user, which you can then crack or replay. Right. So that is the ActiveX controls in Word and how to use it. We get the hash. We can pass it, or you can use invoke relay or impacket NTLM relay X to then relay it to other hosts in the network. 2 different attack paths with that hash, but at minimum, you've received that hash. Now, phishing outside the network, phishing as an external attacker, one thing I've seen is a lot of times organizations are not blocking outbound SMB. So you will still receive that hash because you're not necessarily just depending on that broadcast name resolution. You provided the IP address in here. You provided a very specific IP address to your attack box. So it doesn't even care about name resolution right now. It is simply just sending the connection straight to that server. So if SMB outbound is enabled, you will receive that connection and you will receive the hash. Okay. So that is it for this presentation. I want to pause and take any questions on this. And this is, of course, recorded, so you can rewatch it and you can go through it. I may have gone a little bit fast on this given the time, but any questions on this, I'm here.
Qasim, we did have one in chat here, more on the lines of what if it's not an easy to guess password, right? What type of steps did you take? The actual question is, what if the user's password was not welcome 12, but a 30-character random string, so strong password?
Yeah. So 2 attack paths, right? So first attack path is, of course, trying to crack the password. You may have to use strong dictionaries, strong systems for that. Like we at Blue Bastion, we've got Alienware laptops, which helps with password cracking and then allows me to play Age of Empires after work. But you could just replay that hash. You don't have to crack it. You can replay it to other systems in the network, right? So a tool for that is the impacket relay X. I don't have it installed in here, but it would be something like impacket relay X -TF containing the hosts that have SMB signing turned off. And then you would simply just let it run, okay? And you'd have responder running on the side, and responder then poisons the requests as impacket relay X then takes them and replays them to other targets. So that hash that you received, it just gets replayed. You don't even try to crack it. Okay. Does that answer the question?
It looks like it does. That's oh, here we have another one. So what was the macro saved as? I believe extension particularly.
Yeah, it was docm. So .docm. Right. And there's 2 ways, right? So you could do .doc or .docm. And doc is the old extension, and then docm. Well, the macro itself doesn't have to be stored on its own. When you do save, you save the macro inside the document. So you're not saving the macro separately. So when you save the doc, it's saving the macro. Or when you save the macro, it's saving the doc.
There's no more questions. Oh, it looks like one might have just come in here.
So best way to check if the hash is relayed. Well, before even that, I would say turn on SMB signing, okay? Because then you'll be able to see when somebody attempted to relay a hash and SMB signing declined it. because your system said, well, you are not who you're claiming to be. Another thing you can check for is the SMB, relaying is going to be a very much of a lateral movement move. So Qasim never logs on to 5 different hosts, but a lot of a sudden he's logging on to them. That looks malicious. Whenever you're doing SMB relaying, you're likely doing it against a lot of hosts because you want to see if that relay is going to get me a local admin on one of those hundreds, if not thousands of hosts. So that logging on to multiple hosts is what you're looking for to identify, relaying, to identify the lateral movement. Another thing you can look for is how the authentication happened. I don't know exact event ID, but I believe there will be events left inside the security tab of Windows Event Viewer that will help you identify that. So is there an advantage to using docm versus .doc? I agree that docm is probably going to make the person a little bit cautious, a little bit suspicious. I don't believe there will be much difference. I have used .doc for phishing, and it's just been fine. So I don't believe there's a big enough difference for you to have to worry about that. You could just use .doc. But double check me on that. I'm not very well versed in that. Such as friends and family members. So question is, if we wanted to practice creating a phishing macro down the line with real world users such as friends or family members or Eddie, is there potential damages performed? Or, well, yes, you could perform some damages, right? The first thing is, depending on your macro, you might get detected. And if you didn't tell your friend or family member that you were doing this, that erodes a trust. So always ask for permission. Whatever we're teaching in here, you should have the permission. And preferably documented permission to carry out those attacks, because you want it to be held up in the court. But also, depending on what you are doing, like for example, if you were changing a password, or if you're installing something, or if you were removing something, you could cause issues. So be very careful with what you are using for phishing macros. If you want to just play around, use a virtual machine and install a Microsoft Word trial. That way, whatever you do is contained to that virtual machine. Anytime I create malware, I use virtual machines. So if I do something malicious and unintentionally, not realizing this tool is doing something beyond just what I want it to do, that damage is contained to the virtual machine. Okay? There are ways to get out of virtual machine. There are ways to go beyond the virtualization and break out of that. But if you are worried about that malware, that threat actor is way beyond macros. So that's going to require a lot of extra work and research and skill set for that attacker to carry out the attack getting out of the virtual machine. So always use a VM to test things out. And yeah, you can definitely do that between 2 different virtual machines if you wanted to.
All right, looks like we have all of our questions answered. Qasim, I want to thank you so much for taking the time to do this and walking everyone through it. As a reminder, there will be the recording available on our website, and it'll also go out via email from Zoom as well. And like I said in the chat, I'll send out the chat too, so that you guys can reference that when you go back to look at the lab, which you'll have access to for the next week. So definitely take advantage of that. Other than that, thank you everyone again for coming. Please reach out if there's any questions in the meantime. Yeah, have a great rest of your day, everyone. Thank you.
Thank you, everyone.